Hi everyone, my name is Chetan Khatri, Solutions Architect, Data and Machine Learning for Axion Labs. So today I'm going to talk about functional programming with Scala and its internal systems. So today's agenda is to consider and talk about introduction to functional programming, value-driven programming, understand the Scala's internal features such as immutability and type safety and value-driven programming, and understand the evolution models in Scala, collection types, functions, different type like tail recursion, higher order function, and currying. We'll understand implicit and implicit object and class. We'll understand transformations such as simple and advanced. We'll understand case class, pattern matching, and we'll also discuss about file handling and log parsing examples over there. So let's start with So we'll talk about Scala evolution models. So Scala has got three type of evolution model for the properties and the variables. So first is you can declare, I hope you can see my screen. Yeah, you can declare val. When you say val and the variable, that's immutable. You cannot change that. So one is immutable. Second thing is that is eager execution model. So once you declare, it will get executed, kickstarted at the same time you declare it. It's memoized. Memoized means it's saved in your cache memory of the compiler. And the def is lazy and memoized. So when you declare that, it won't execute at the same time. But when you call that function, because Scala has everything as function, even the property is a functional value. So when you call that in a println line, at that time it will get evaluated and will return the value to you. And lazy and lazy is by default is lazy, but not memoized when you say lazy val, right? So how we understand that? We'll execute this code. So if you execute the X, I have a code block, and in that I'm printing the string and saying math.random. So for this, you will see that is eager and memoized. So output will be same here. Def is lazy and not memoized, so output will be different. And lazy val z is lazy and not memoized, so you will have same. So let me trigger the run. I hope that's happening. Yep. I don't know why the hell is saying compiling Kotlin. So the Scala, yep. So here we go. X is eager execution model and memoized, so output is not computed again when you call second time. It just caches the memory, keep the value, and second time it refers to reference to the same address of the memory. So you see the same output here. Computing Y is different output because it is lazy and not lazy. It calls every time it does. And then we'll talk about Z, which is lazy and not memoized. So it doesn't cache it, it just go ahead and compute every time again. So you see that the output is different here for that. Sorry, for this output is different because I'm sorry, it's lazy but not memoized. So that does mean every time you compute that, yeah, sorry. So so main difference between val is eager and memoized, but lazy val is lazy execution model and memoized. So it's memoized, and when you call it, it actually triggers when it is called. When it really get evaluated when it called. That does mean when you say Z at the time it is evaluated, but it's memoized, so you will see the same output here. Memoized means it is cached in the memory, unlike def. So X is triggered eagerly at the same time you just uh, declare that, but lazy where is only called when you actually call that. That's the difference. Now we'll talk about currying function. So as we spoke on higher order function and tail recursion function and default transformation in advanced and simple, now we'll talk about different type of function called currying function. This is kind of different pattern of writing the function and the design. So we have a case class called, we have object called currying, case class message, and value is a property of that object. And then we have telco provider, source name is a property. It has a method called sendText message, and it has a message of type M and can send the message as a printer. And this is side effect driven call anyway with println. And Scala's API way of writing function using def communicate and message t telco providers unit t dot send text message m currying function. You communicate form, you have argument of message type message, and then equal to. This is where you will see that IntelliJ will tell you that function is currying dot telco provider. So you're saying the equal to, you get another argument to the function. There is a other type which is telco provider, which we have as a class, and you say s is an object of that. Now you call s dot send text message, the property of m means message here. So this is called currying. When you have one argument equal to another argument you pass, that's called currying function. Communicate from different way. You can call same function different way. That's called non-currying way. You say m message and then bracket you say s telco provider, and then you say s dot send text message m. The only difference is that when you say equal to here, it really becomes the kind of currying, and you say here arrow, right? That's the difference only. And then message with special care. In this example, I have message string if message.trim to start with $, then you drop the $, and give the message as just give the message. You can do same thing with the pattern match in this way. You can say message match case x if x.trim start with $, then arrow syntax x.trim drop 1, else underscore means any default condition else, and give the message back. Now going back to main method, main return the unit means nothing. Then you equal to here. Yep. Calling Scala, or you don't do this, fine anyway. Yep, it's better to write unit. Calling Scala function, I am calling communicate message hello telco provider, this is Vodafone, and calling Scala API function, you say telco provider idea, send text message hello. So this is the one. Calling currying function, you communicate from, pass message how are you doing, and that communication is a function, you pass the telco provider. This is this one you passing, right? And calling currying function second, you can pass communication from different way, message, and then you provide telco provider here value. You can also use transform normal Scala function to currate function. You say communicate underscore dot currate. Now you can uncurry from curry function. This is curried normal function, function dot uncurried, pass the communication function. We come back to normal. Let's call this thing. So we hope it runs. I just wrote this some time ago. Yep. So text coming from this is Vodafone. You can see all the functions we'll be calling. Last one was this correct function, Safaricom. When you say question mark, it's coming here. This is a message. Airtel Bharti and Jio Telco. You can see Jio Telco, Airtel Bharti. Right? This is a design pattern of writing different way of Scala methods and functions. This is called correct function. Thanks everyone.